Hello everyone, my name is Annika Palapothu and I'm a 7th grader at the Harker School in San Jose, California. My project uses artificial intelligence to predict or diagnose diabetic eye diseases using computer vision and convolutional neural networks. You might be wondering what my inspiration behind this project was. The Foundation Fighting Blindness is a national nonprofit organization which my family volunteers for. I was inspired by their work they do and thought of working on a project that could help them on their mission. One of the major eye diseases in the world is called diabetic retinopathy. Diabetic retinopathy is the leading cause of blindness in the working age population of the developed world. The U.S. Center for Disease Control and Prevention estimates that 29.1 million people in the world had diabetes, and the World Health Organization estimates that 347 million people have the disease worldwide. Currently, detecting diabetic retinopathy, or DR, is a time-consuming and manual process that requires a trained clinician to examine and evaluate digital color fundus photographs of the retina. By the time human readers submit their reviews, often a day or two later, the delayed results lead to lost follow-up, miscommunication, and delayed treatment. As you can see in the picture above, the retina, which is the darker circle, starts fading away in the diseased eye. However, in the healthier eye, you can see the retina clearly. There are 5 cases of DR: no DR, mild DR, moderate DR, severe DR, and proliferative DR. Here are examples of each category. Let's see a small video clip on diabetic retinopathy and listen to experts talk about this disease.
Diabetes is a disease that affects blood vessels, and it affects blood vessels all over the body. Unfortunately, diabetic damage in the eye leads to vision loss.
Diabetic retinopathy is the most common diabetic eye disease and is a leading cause of blindness in persons with diabetes. It is caused by changes in the blood vessels of the retina. The retina is the light-sensitive tissue at the back of the eye. A healthy retina is necessary for good vision. In some people with diabetic retinopathy, blood vessels of the retina may swell and leak fluid or blood. In other people with diabetes, abnormal new blood vessels grow on the surface of the retina. At first, diabetic retinopathy may not cause any changes in vision, but over time, diabetic retinopathy can get worse.
My project is to attempt towards finding an automatic way to classify a given set of fundus images using artificial intelligence based on neural networks, algorithms, and classify the retinal disease based on the severity. Let's discuss the architecture of my program. It has 3 main stages: training the data, validating the data, and testing the data using TensorFlow libraries. The 3 main challenges are classification, segmentation, and detection, coupled with transfer learning and parameter tuning. I adopted ResNet for DR image classification. In this slide, let's understand how convolutional neural networks can be implemented. In a CNN, each neuron in a layer is connected to a small region of the layer before it. The convolutional layer has filters doing dot products to the input of the previous layers. In the ReLU layer, it sets all the negative values in the matrix to 0, and all the other values are kept constant. In the pooling layer, it shrinks all of the image, and in the fully connected layer, it takes all the other layers before and stacks it. In the next slide, let's analyze the application testing results. I trained the model, and the loss that came at the 10th epoch is 0.29739, and the accuracy is 0.8825. The predictions of the test had been done correctly. After running a few more iterations, the accuracy improved to 95%. Here's the user interface to predict DR. The first step is to take the fundus image that needs to be tested. The next step is to upload an image to the cloud, where my application is running. Then click the predict button and see the result. So let's analyze the results. Around 5,000 images from the dataset were saved for validation purposes. The final trained network achieved a 95% accuracy, and the classifications in this network were defined numerically as shown in the slide. So let me explain to you the results using a confusion matrix. If you look at the second column, My application correctly detected 609 people as having mild DR. And the false negatives are 34 with no DR, 95 with moderate DR, 25 with severe DR, and lastly 4 with proliferative DR. Here is a table showing the results of my output data. Here is a graph that shows the result of my output data. These are all different ways to get the same exact information. In the future, I would like to make a few enhancements to my code, and so the application could be used to predict several other types of eye diseases in addition to diabetic retinopathy. I could also enhance the code to quantify the region of the disease to help the ophthalmologist to detect the progress of the cure. In conclusion, the proposed approach using CNNs had a high accuracy, low learning loss for classifying DR images, hence offering a consistency of interpretation on the specific diabetic retinopathy image and able to assist ophthalmologists in making an appropriate decision. Here's my bibliography. Thank you.